So good morning, good afternoon, good evening to all the participants for this webinar. It takes immense pleasure to welcome you all for this very interesting session focusing on modeling. As you all know, modeling is an area which creates a lot of tension as well as excitement. So keeping this in view, we decided to have this as part of this, this topic as part of this session today. My name is Suresh Iyer. I work for JMR Infotech as Executive Vice President. To introduce a little bit about JMR, JMR was established way back in 2007. And over the past 14 years, it has delivered more than 200 projects across the globe. It has 30 plus offices across 5 continents, and it is well known for implementation of risk and compliance solutions covering the entire length and breadth of enterprise risk management as well as compliance areas. Next slide, sir. So today it gives me immense pleasure to introduce my other panelists here. I have Mr. Kannan, who comes with over 4 decades of industry experience. Earlier, he was chairman and managing director of Vijaya Bank, one of the large banks in India, and currently is on the board of several companies, and also is an advisor in the area of risk management. It also gives me immense pleasure to introduce Dr. Ashok Nag. He is a well-known personality in the area of modeling. He was a senior executive of the Indian Central Bank, Reserve Bank of India. Post his retirement, currently he is heading the entire risk management practice in a listed company called 63 Moons. So he has, he's widely known for working extensively in delivering models, especially in the area of credit risk. Next slide, please. Just to set the context, this is what we thought we should cover today as part of our this important webinar. So to introduce all of you to the modeling framework, and also to touch upon how to implement models to meet your both risk management as well as IFRS 9 areas. What are the key approaches, followed by question and answer. So if you have any questions during the course of this presentation, feel free to type on the chat box. We will pick it up in the Q&A window. We strongly believe, good compliance, solution gives good comfort to your bank and organization. It creates value, and value creates shareholders' wealth. Next slide, please. So coming to the modeling aspect, in the past, it was largely confined to academicians. I myself worked for a large bank for 25 years in 70s and 80s. Whenever we used to discuss about modeling, we always used to feel, oh, it is a forte of, academicians who do a lot of research, and it is part of the R&D team. And very rarely I used to see bankers diving deep into adopting modeling as part of their own day-to-day work. So decisions were largely judgmental and less influenced by models during those days. And always we used to believe as bankers, modeling is still evolving. It will take some more time, some more R&D before it actually fructifies into a useful tool. So that was a feeling we had in the past. And very few large banks, even in those days, used to adopt models. Compared to that, today we see statistical and mathematical econometric models are widely used by banks. In fact, quantitative techniques are very popular. Whether you go to a bank or even those investors in the stock market today, they widely use quantitative techniques as part of their day-to-day decision-making process. In fact, models are actually imagined, conceived, and built with an intention of solving specific problems. Other good thing that has happened in the past 1 or 2 decades, the huge advancement in the computer science industry and technology. Today, you can churn large amounts of data easily in minutes and get the results. So that has really improved the usage of modeling in our banking environment. Also, today we have some of the modeling tools like R and Python, which are easily available, easily understandable, and easily leveraged to develop the models which we want to use and deploy. So today, regulators also insist on banks using models for PD, LGD, AD computation when it comes to Basel or IFRS 9. Some of the banks which made rapid strides in developing and adopting models may need help and support in terms of model validation. So we at JMR and Basel Group, we have good amount of expertise to help and support banks in this very important journey. So with this brief introduction, let me hand over to Mr. Kannan for his perspective on the modeling and its usage in banks. Mr. Kannan, sir.
Thank you, Mr. Suresha. Greetings to all my banker friends from across the globe. Welcome to this knowledge sharing webinar series brought to you by Basel practitioners and JMR. If you remember, in this series about a month ago, that is exactly on 16th September, we brought to you Dr. Nag to talk on operational risk management. We saw at that time that each bank or institution has unique systems and procedures being followed, and hence operational risk cannot be an off-the-shelf solution and needs to be customized. But then for building any risk solution, we need to first firm up on the model, which is easier said than done. Now then, what is modeling? The British statistician George Box once said in 1976 that essentially all models are wrong, but some are useful. Many people in the field of statistics try to develop theoretical models aiming to predict the behavior of a certain process. For instance, the selling trend of a product or the number of defaults in a portfolio. The idea of this quote is that every single model will be wrong, meaning that it will never represent the exact real behavior. But even if a model cannot describe exact reality, it could be very helpful if it is close enough. Since a model is a simplification of reality, it essentially has to be wrong. Though we have found saying that history repeats itself, the past is always not a perfect predictor of the future. Assumptions used to simplify a model eliminate various aspects of reality's complexity. And so, unexpected results must be expected. Unexpected results are the primary target of risk management. Now, what is needed of a model is a reasonable probability that actual results will not deviate from predicted results by more than an acceptable margin. An organization must define for itself reasonable and acceptable in its particular business context. These definitions make up the risk appetite of the model owner. They define how far assumptions can be used and how conservative must be any rule that drive action from the results. Like Mr. Suresha mentioned, today regulators across the globe expect banks to use models to predict PG, LGD, EAD as part of Basel and IFRS programs. These models are imagined, conceived, and built with an intention of solving a specific problem or for a specific purpose by those who understand the fact that financial risk is not a random phenomenon that appears due to human errors, variable market conditions, or otherwise. It has a trend, a cycle, or pattern which can be identified and modeled. Now, statistical modeling is an art in itself. And for that, one has to be an artist who can imagine, explore, and interpret the dance of variables, conditions, and assumptions. Due to advancements in computer science and technology, the ability to process large amount of structured as well as unstructured data in near real time has made it possible for machine learning to emerge as a business enabler. A model basically consists of three components: an information input component, which delivers assumptions and data to the model, a processing component, a reporting component. Model lifecycle also includes various phases like model development, implementation, validation, approval, monitoring, change management, and retirements. Now, having seen how complex it can be for deciding on the model, let us now listen to this complex subject from a seasoned professional, that is Dr. Nag, who has developed and implemented many risk models for multiple banks across the globe. Like Mr. Suresha mentioned, Dr. Nag was a senior executive of the Reserve Bank of India, which is the central bank regulator for banks and financial institutions in India. Post his retirement, he is the head of risk management practice at 63 Moons. Dr. Nag has extensively worked on model development and validation. So with this small introduction, I would now request Dr. Nag to take over and deliver his speech. Thank you, Dr. Nag.
Thanks, Mr. Kannan, as well as Mr. Suresha. I think Mr. Kannan has rightly said about the things a model, that is, there is a one is the techniques, assumptions, and the understanding of their subject matter to which the model. And what is a model? Model is not a replica of the reality, it is a kind of abstraction of the reality. That means you cannot really model everything. For physics was given to a person to actually model the climate changes and its effect on the environment. Now, of course, people are trying this for so long. So many models have been proposed, have been used. And this is what is a new model which has been proposed by our Nobel laureate this year, is giving a much better result, predicting something what is going to happen. Nobody can really model everything which affects your weather, either at a macro level, say at a country level, as a maybe micro level, maybe at a particular, say, zonal or the district level. So a model is a representation of reality or the idea, but not reality itself. That must be understood. Now, question is that this reality has been understanding has to come from the, suppose the banking, from the domain knowledge of the banker. Is it not possible for any statistician of highest quality to distill every domain knowledge which has been acquired by a banker over say 25, 30 years, 40 years? When human being was actually giving credit, credit is basically credit. One thing is a credit is basically a kind of a character. And earlier 5C characters, 4C characters. This is the human beings, which has a brain, which is also a processing computer. Informations which are available, textual, all kinds of information, and they used to understand a potential borrower whether it is the credit worthy should be given or not. It doesn't mean that it will be always correct. There will be always a kind of a mistakes, but still people used to get. Now there are various kind like dynamic liquidity. We want a forecasting model. Some model is used for forecasting, Like when you are giving credit scoring model, you are trying to forecast that what is the probability, likelihood of this particular person's or this particular corporate is going to default in what time horizon. For example, so in the case of the when you do a diagnostic checks of a body, all kinds of tests give the results. What is the use of the result? A doctor who understands the result will say that what disease you are likely, even if you do not have it, what is the likelihood of that disease and what precaution you should take. So this is same thing is that in the model in the banking sector, we can either use the forecast, we can understand that what is the driver of a particular default to understand the driver is also is required. For example, we discussed in the last time operational risk, what is the control mechanism you can have so that you can mitigate the possibility of happening that particular event. So a model addresses the questions of how something works. Let's understand that the dynamics of the system, why something is happening, which is the thing going wrong, that is why it happened, okay? Or what may be the effects of perturbations. Perturbations means what we call today verifying. It is very important tool for regulations which has happened across the world called stress testing. What happens if your top three borrowers suddenly there is a deterioration in your credit quality? Say AAA rating becomes a BB rating. How does it affect your own balance sheets and profit and loss account? So these are the called stress testing. And this stress testing, there are various ways you can stress a particular model. When you do a stress means what? A particular variable which is affecting your target variable. If it moves adversely against you, then what happens? The target variable's outcome. Is it going? That is what the stress test. So these are the use of the model. Next slide, please. Next slide, please. So what we are trying to, trying to model in a bank, we are trying to basically, for example, credit scoring model is basically to find out that whether bank should give credit to this particular retail borrower. So if you want to give a credit scoring model, you have a certain cutoff kind of a threshold parameter limit. If the score is beyond that, you say that okay, our line manager can give the credit up to this limit. If it is below that, maybe a second level review has to take place. If further below that, you should reject it outright. Then loss given default. How much are we going to, if loss actually occurs, how much we are going to lose if the loss is occurring? Exposure at default. If I have to model exposure at default, I would like to know if default is going to occur, is the exposure is going to increase very substantially. Why? Because it is our understanding from the banking experience that when the borrower has a better knowledge of its own financial health than the banker, it is obvious. So when borrower is trying to know that it is likely to default its payment, scheduled payment, then it will definitely try to exhaust the limit as much as possible before this become evident to the banker that borrower is in a problem. So that is the exposure at default has to be. Otherwise, we can take the outstanding only. Then customer attritions. What are the factors that is driving the customer's advert? What is the most likely loss in my investment portfolio? There is a market risk. So purpose of modeling is two things. One, it allows you to take a decision either to give loan or to give loan, either to increase the credit limit or not, or you have to performance evaluation. You have made a promotion. You have tried to see the something. Bank, suppose credit card, you have made a promotions. Has it really impacted? Has it really brought in new customers? Has it brought in new customers? What about bringing in? All these questions, evaluations, you have to model. Because then only you can say that is it possible to estimate that. Next slide. Okay. So types of models. we are giving you three types of model, and I would say that that could be another type of models, which is coming to the, which is a, the called, it's not exactly statistical, but it is database data science. I will talk to that also. Now, generally we have so far, there are three types of models in credit risk: heuristic, statistical, HP, and it is true for every kind. Heuristic means basically you have not crunched the data to the maximum extent possible and then distilled the variables of having substantial information about the outcome variable, which is your target variable. If default, that means or not default, is the target you are trying to model, and what drives defaulting on its obligations or her obligations. So that is means what are the characteristics of the borrowers or the borrowers economic kind of aspects of the functioning of the borrowers. Is it possible? That can be done only by domain knowledge. Most of the models in the earlier ages were basically heuristic model. That means the people knows that these are the variables that are important. Then there is a statistical model. The statistical model is a data driven, data on outcome or dependent variable and possible explanatory variable. So you are having some prior understanding of the possible variables that may affect the the behavior of your borrowers, that may affect, suppose even you are running in HR organizations, or you are a HR head of your bank, you are having a recruiting process and you want to understand where that is the variables which you have there, which can be measured for a potential kind of a employee, a potential kind of a entrant. Okay, and then you try to see that how this forecast has pointed out later on. Then you can see that which variables are really had a good kind of information or predictive kind of capability of that particular outcome that the person has really come out as an asset organization. So it is a statistical kind where data is telling you these are the likely kind of a variables, impacting variables which are affecting the outcome variables. Then there is a HP model. We will talk about that. Analytical hierarchical process is decision making tool. It is also called multi-criteria decision making tool. That means this basically the difference between heuristic and HP is that heuristic model starts with the domain knowledge, filtering the domain knowledge, identify the variables in terms of the hierarchy of importance, okay, and then tries to give some weight, because ultimately you have not a single variable, you have multiple variables which affects the outcome variable. Now question is that every variables cannot be different same weight. Something is more important than something else. Okay. Now heuristic and AHP, the difference is that heuristic weighting diagram, that which variable should be more important as a forecasting or the information, has a more higher level of information, better information about the outcome variables, that is decided by their domain knowledge people. They say that, okay, give 50% weight to this variable, that his person's is a a married and vis-a-vis non-married person who is buying a home, and for home loan, a married people much better credit worthiness than an unmarried people. Okay, because married people have a much stake in the home. So this is one kind of argument. Now, how much weight? Your domain people, everybody sits together, say, okay, let us give a in the total excluding model 15% or 20% weight to that. HP model takes those variables which have been identified with domain knowledge, but they decide about the weighting diagram in a little bit different. I'll come to that when you go to an example. But this is also called multi-criteria decision method. Means there are multiple criteria to find out that whether a particular project by an organization should be taken or not. Okay, and then they will be identifying the criteria from the domain knowledge or maybe some data crunching. Ultimately, weighting diagram is a operation research problem. So that operation research problem is solved, and we have a AHP model. Now, apart from that, which I have not extremely covered in this, because we are talking about the subject matter is statistical modeling, but today, because of the computational power, the traditional statistical techniques which are developed basically to take inference from data where you don't have such huge information data as we have today. And then your data crunching, data manipulation, data kind of taking information out of data in your today's your computational part, like our human brain does. Similar kind of a technology is emerging, like your neural net, like other big what we call the big data analytics, and banks are very much using it. And it is becoming more important for the bankers because what is happening today in the digital area, there are you have been competitors called P2P kind of platform where the people are the bankers are not necessarily meeting physically, they are borrowers or the potential customers. And that how does a platform which is a lower probability of default than another customers, okay, so that they kind of a loan disbursement. But anyway, that is very important coming here, and that is a something which does it what you put all information. So your domain knowledge, importance, which is then statistical modeling, is becoming a little less, not exactly less, but little less. You can say that. Okay, because see, for example, I give you very important examples that this is a marketing example, of course, not the banking examples, and it became a kind of a pedagogic example. See, when we are doing your large kind of a okay, stores, and the chain of stores, they have a huge kind of database, okay, and their important point is that they would what crunching this data. How do I increase the kind of a what is the basket the customer buys? Can I analyze this customer basket and tries to put the things together so that customer says intends to buy the entire thing? And one of the pedagogical example came, and no domain knowledge was there. They just put entire basket analysis of all the customers who have purchased from some stores of the Walmart, and found out that the during the weekend, the the married white people belonging to certain age group, okay, comes to buy the diapers for their child, and they also most likely to buy a beer bottle. So what they did it after looking into this entire analysis. Of course, this is an outcome of the data crunching. Now, does it make sense? That comes to domain knowledge. The domain knowledge says that yes, it makes sense because there is a logic behind that. So what they did it, they changed the marketing technique. That means putting the beards near the diapers in the huge store of the Walmarts, and they saw that there is a at least material increase of the shelves of beer because of that. This is data crunching. This is also kind of a techniques for taking data to create your marketing kind of a strategy. Similarly, banks can do it also. For example, insurance people do it. One of the basic cases there that when people give the insurance that they in USA, there'll be differential kind of a premium for different kind of customers. It's not unique. So what is that this differential premium is given? They found out that the young unmarried males below 30, 20 to 30, when they buy a red racing car, they are more likely to experience a kind of accident. So the premium for that particular type of car for particular type of customers will be 20% higher than the others. This is the database digital tool. Okay. Now go to the heuristic. Like we are going to heuristic model. The best example of heuristic model is camels. It started in 1958, for something 86 or I think 68 sometimes. Okay, it is a camel. Initially, it was camel. Then it's a camels. Rating this camel is a capital adequacy, asset quality. Most of you know these things. Okay, serious equity, sensitivity. S was added. Sensitivity market risk. So this model is meant for ranking of the banks, or they identify the banks which are becoming vulnerable. That means they are having much more risk to the objective of the regulator. Okay, so then they have this 5 kind of gradings which is done in the this is the USA authorities are doing it, and this is the kind of banks are sound in every respect, generally have components rated 1 and 2. So it is this rating, there will be guidelines which bank will be given 1, 2, 3, 4, 5, and they had a certain weighting diagram. And based on the weighting diagram, they will have finally what is the 1, 2, 3, 4, 5, where this particular bank is standing at. So this is heuristic model. The entire model is based on this camel's capital adequacy. It is a level 1. This capital adequacy will have a sub-level, level 2 parameters. Say what is the level 2 could be, what is the percentage of tier 1 capital in the total capital adequacy, which is the regulatory capital bank is having. So similar kind of things like level 1, level 2, level 3. And then you have to weight diagram for every level within sub-level and gradually roll it up to the final, what is the final score of a particular bank. This is heuristic. This is a typical heuristic model which has been used. For example, if you look at the FICO scores has a certain kind of a data crunching, but ultimately it is a heuristic model. What is the history of your loan behavior, loan repayment behavior? So I think they give a 50 or 60% of the weight. Okay, so these are all after data crunching and giving a weights. That's the heuristic model in some sense. Next. Then we have a very famous statistical model. This is a this is the credit scoring or the credit probability default in some sense you can say, but it is a vertically credit scoring model, and it was done for the corporates, and it was done in 1968 by a Stanford School professor, assistant professor Altman. It's called J square. What exactly what it did is that it's a user called statistical technique called multivariate discriminant analysis. Discriminant means what? You are discriminating between a potential defaulter and non-defaulter. Okay, data should be able to, given certain parameters values, data should be able to classify a particular potential borrower in the default group or non-default group. So what they will do, they will try to see the all possible kind of informations which is there. Earlier, when Altman started this project, that time the basic thing was the ratios, various kind of financial ratios people use, and it's the chartered accountants everywhere they do it. Okay, so if you are to tell a particular institution as ongoing concern, okay, so there are kind of a techniques as your chartered accountants do it, and they say that it is the ongoing concerns. This means it is a viable concern. It is not going to have any kind of a default or become insolvent in next 1 year, 12 years. So this is the techniques are called multivariate discriminant analysis. What it does, it combines many numerical variables or some categorical variables which can be converted certain kind of numericals, say 1, 2, 3, 4, like that. So you have many kind of variables, a combination, linear combinations of these variables with a certain coefficients or weights attached to them. You will get a number. That number, certain below threshold, will be told that it will be classified as a potential defaulters, and some less than that will be classified as a potential non-defaulters. So this is done. What he did, he has called this, instead of defaulters, it's called distressed and non-distressed. That means a particular corporate will become a distress within 12 months horizon, or it will remain non-distressed. So he first collected a number of ratios which are generally used across the companies for various kind of a financial health measurement. Number of variables are there. The variables are classified into 5 standard ratio categories: liquidity, probability, profitability, leverage, solvency, and activity. 5 are selected as doing the best overall job together in proportion of the corporate bank. This is done by looking into the corporate and identify the companies which became default when the beginning of the year. What are the variables, levels, and they defaulted within a year, and they classified them into this, and they found out that this is the only 5 variables which are becoming most important and what the best classifier or discriminant. Classifier and discriminant is almost same. Best classifier, the value Z will be the overall index, and beyond a particular value, this will be classified as a defaulter, and below this will be potential non. Statistical techniques of people say credit scoring or so. Of course, this particular differential is a 1-0. It will default or it will not default. It is a not exactly giving a probability because the Z probability will be only 0-1 variable between 0 and 1. We have got other statistical techniques. We'll come to together. Next. So, what is the analytical hierarchy process? Analytical, I told you that this is. Let's go to. You have some examples of there. Measurement of credit risk. What are the kind of a weights can be given. We have given a particular example of we have done in the case of Financial Service Commission Mauritius. Ultimately, after this analytical process, we have got this kind of a model which is built up, and their weights are there. We are not giving the weights. Next, go to next. Go to the next. We'll just be there. See, I will just give you example of the little bit of HP. Here, I am giving the first the paper which was written by this Sati, who was the originator of the particular technique. And this was the problem he was trying to solve, that I have 5 universities. I have to get 1 university admitted at what time, where I should get admitted. See, you have got admitted 5 IMs. Okay, which IMs you should select? What are the criterions of your selection? How do I hierarchy? How do I really put them in a kind of a hierarchy that this is the most important criterion, this is the next important criterion, and this is the problem which is solved by this particular HP process. And this, you can see that this is the one why these marks are given. So what basically HP is doing here, that means if you give equal importance, that means these 2 variables, I cannot say that this is more important than the other one. If you give 2 moderate importance over one another, so one is giving 2, another is giving 1. So you are able, the basic philosophy of the HP is that human beings can, this variable is more important than the other variable, but it is not possible for them humanly to really classify 5 and 8 or 20 variables together, rank them consistently. That means basically, if I say A is greater than B, okay, if A is greater than B, if 5 is greater than say 3 is greater than 1. But when you're giving weights like this, 20 or 30 or 70 variables, it is possible that you can make such mistakes. So it is the job of that technique is to create a consistent kind of a rating, grading system. After this grading system, you only give said how much, 1 5 or 2 5 or 2 3. That means 1 is 2 and then the 3. This is the ratio of what you call the importance I am going to give it. If I say that it is 2, then it should 3. This is the differences. And this is next slide, please. Using this technique, there are a lot of kind of use of these techniques are there across the world, and people use extensively for project identification, project selection process, do it across the world. And this is this particular example, which you can see that what kind of a location, which is the between ambience, what is more important, 1:7. Okay, 1/7 and the 7. That is, ambience is much more important than location. Okay, so location should be I'm not going into the basic in details of the techniques. And we, as a banker, that is one thing we should understand. We should try to understand the logic, the philosophy of the technique, rather than the numerical or the statistical properties of the techniques. Whether the technique is a, what are the kind of a what are the kind of what are the kind of a logic, what are the kind of a calculations it is doing. So what is important for us that if you want to build a model without really only your data crunching by itself, like what Altman J square was there. Altman did not decide it himself. He did not decide himself about those variables x1, x2, x3. The variables came as an outcome or result of a statistical processing of data. That means the variables which have a much more discriminating power, they got automatically selected in the final kind of a linear combinations, which is the best discriminator. Here, I, as a domain people, are next slide, please. So we have got all these three approaches, pros and cons. Okay, but one thing is that we are not looking into the your data science based neural net other things techniques here. Like there are very sophisticated kind of techniques have emerging, but they require a lot of data. If you want to use it really, you have to have sufficient information for them, and we'll come to that with the machine learning of things. We'll slightly cover them later on. Okay, let's go to the next one, because we have to finish the
it's already 5:50.
5:50. Yeah. Now, what is there? See, point is that what is the steps you have to take for credit scoring models? Okay. The credit scoring is a classification problem, of course, as you are giving your marks in 1 to 100 or 1 to 10, whatever you decide it. So it is a predictive model. That is, higher the score is, the less is the probability of default in future. And credit scoring as well as credit rating are conceptually equivalent. Rating is basically sometimes is done what you give a score, and then you decide that which is the score will tell me that they should be classified as AAA. So that is also a use of the credit scoring model. Next slide, please. Yeah, limitation of the credit scoring is that you are only looking at people who has come to you and whom you have given the score, and who have given your say credit or outstanding. Then after that, you after 1 year, 2 years, you are also looking at their default kind of a behavior. You have not got a underrepresentation of the people who have left, who have not been given. Either they did not apply to a bank, your bank, or you have rejected them. And if these rejected people might have gone to another bank, and they might have done very well in the other. You do not know. This is the information not available to you. So this is a kind of a, you can say a limitations of your thing. That is the bias can be there. Those which have been rejected, what is their behavior? You are not following it up. Okay. So it's like that, if you are trying to create a vaccines, you have to see that whom you have given vaccines, how they have responded, if they are affected by this particular virus, and those which have not been given also virus, whether that also then vaccine, what is their performance after they have also received the virus. That you cannot do in the case of credit scoring, where as a bank, you do not have the data, the performance of the people whom you have rejected. Okay? Now, this statistical approach step by step is what? Decide about the target customer segment and product segment. The major idea behind this that you must know that this particular customer segment or product segment must be having a common kind of a risk drivers. That is, they are affected by a common set of variables. If you believe that this, say, for example, a MSME, borrower and the 1,000 crores, say, corporate borrowers cannot be scored in the same kind of a model. It will be quite useless to get a single model for them. Nobody should do it because your domain knowledge says that their risk drivers are completely different. So it is your choice to find out that how do you do that, that what is the common risk drivers and who is the product segment, customer segment must be selected first. Once you select that, you do a simple selections. So you have, what is your data you have? You have the data of your customers who have been given the loans with a certain kind of credit scoring, and maybe last 5 years, 6 years, you have their credit behavior. Then you are trying to model them. Now question is that you have a 1 million customers, suppose, or 100,000 customers, okay? Am I going to model everybody taking them? No. So I have to select a sample because the larger the models, the larger your cost of the managing the data, because you have to look only collect the data, you have to only sanitize the data, see the data is the quality of every record, and then try to see the records which are having a minimum quality, minimum kind of a missing data, I will accept them and put in the model. So this is the sample selections. Then the variable selections. What are the possible variables you have in database? That is important. You may not have collected many information also. Is it possible to collect some information from outside? Those things are important, the variable selection. Once you have the variables which are potentially predictor of the default behavior of your team, then you have to do the statistical kind of techniques to find out that which are the best discriminator or which are the various kind of techniques are there, but you have to find out them and then calculate the what model you have to fit it. For example, you can have a your discriminatory analysis, multiple discriminatory analysis. You can have a various regression analysis like logistic regression. We use logistic regression for the getting a probability of default directly from there. Okay. If the result is satisfactory, then you said one of the things statisticians do it that you collect, suppose, 100,000 records which you want to process, but you do not deploy enter 100,000 for your model building. Maybe you take 70 or 80,000 and 20,000 you keep aside to test that whether model is working for that 20,000 which you have not looked into for building the models. So this is the kind of a back testing, or this is the testing. So one we call the test database, another is the training database. Training database, another is the validation database. That is the one thing, main thing. Next. That is the validation is okay, then deploy the model. So this is the variable selections, okay. Basically, your idea is that variable selection that does default rate varies between genders. Then if it varies significantly, then gender is an explanatory variables for default. But it does not vary. The distribution remains identical. It doesn't matter whether they think, then don't select it. That is one of the way of variable selections. But there could be other ways also. Next slide. So this is the statistical methods for this regression models, probit and logic regression model, discriminant analysis. Then I have given certain support vector machines, neural network. These are, although I am telling it is statistical, but they're absolutely not exactly the traditional statistical methods, because they are not having a certain kind of a immediately giving you likelihood and the probability of and these things. So that is a certain kind of a probability with respect to the default category, your error. But these are able to crunch huge amount of data and can give you a result which you can apply and then say this thing. As I told you, the examples are there. But one of the major problem also is that there is no model, there is no technique which is a panacea. This kind of model, neural network, support vector machines, these are almost only a data crunching based model. Not any particular probability assumptions are involved, but they are also sometimes become fragile in the sense that they change over time, sometimes very quickly. And that time, why this kind of models require calibrations and read kind of validations almost much more faster. And one should do that. One of the examples I have seen that people use a lot of kind of forecasting of the like your algorithmic trading are all based on this kind of a neural net kind of things, but they have to be always kind of a very frequently updated the models so that because new information is coming, and that new information if you feed into this particular neural network building process, suddenly we get a different kind of report. And these models need not cannot be explained so easily that which is the driver of the your problem. That is very difficult to say. Next, there are programs are available. You can easily do it. You can you do see today it is not the availability of the programs or the techniques, application of the techniques. What is important today is more, is this technique applicable to the data you have it? That is important. Is your data is really amenable to this technique? Because this technique also requires certain kind of a data level, integrity data kind of validation or data kind missing data element. So you have to see that the applicability of these techniques to your data is something has to be decided, and that requires a modeling kind of expertise, that to some extent statistical knowledge, but otherwise certain techniques can be used, but you don't require to bother about the programming part of it. Next. So I have given a credit scoring detail project report. You can see that a particular auto loan giver, okay, that a financing company, they are having a model and they wanted to validate the model by a external consultant. They felt that this should be done, and this consultant followed this particular kind of they took the data and entirely did build the model themselves, and they found out this new risk drivers and this test that they do. Okay. So this is basically this same approach you have already talked about. They are following the same thing and try to arrive at what are the key risk drivers. You can see that 1, 2, 3, 4, 5 risk drivers they found out, and they say that this model is better than what their bank was using earlier. Next. So let us try to click that. Go ahead. Okay. Now what we are trying to go to that. Now we are trying to modeling probability of default of corporates, exposure attack default and loss given default. What we should do. So there are first we have to know what is the definition of default. As a banker, we know all BCBS definition, and nowadays we are coming into IFRS 9 definition. Actually, IFRS 9 does not define what is default. Okay, what it says that your expected credit loss. Okay, when you are talking about expected credit loss, that means your credit, if it's a deterioration is there, then also that is a credit loss. Okay, so that means that if your deterioration, that means your expected credit loss increases. Why? The likelihood of default increases, so your expected value also goes changes, because expected value is actual your your payment into the probability of that payment in future, because you are talking about future. The one of the things with the IFRS 9 changes from BCBS, IFRS 9 is talking about either lifetime expected credit loss. We'll come to the last type. What is that? So they are talking about much bigger horizons. Okay, that is what is being done. Next, go to that. Go to the next. Now there are two methodologies we are talking about here: probability of default. So what underlying thing is that you have already got the rated corporate customers, either externally or internally. Internal rating can be based on the credit scoring model. From there, you have got a credit rating. And now what you are going to say that, because you are doing a ratings, because IRB approach, what the BCBS says, it is internal rating based approach. IRB is internal rating. Once you have done internal rating, also BCBS says, and it may vary from jurisdiction to jurisdiction, but what BCBS says that the minimum this many grades, I think 7 or 8 grades must be there, and that should be default grade. And you should classify your borrowers into these grades and then assign a kind of your probability of default for them based on your rating. So what is the, and once you get this PD, LGD, AD, then you can have expected loss, and you can also create the distributions, and you can calculate the what is the percentiles of the where you can lose. That is what you are going to give a capital for that. 99% of it. That is how much loss you can make. That will be your capital you have to keep for your the regulatory capital. So this is the crux of the matter of this BA. Now there are two methods of there. One is cohort. Cohort is the simple. How many people are there? How many have died? That defaulted. That is your rate of mortality. Another duration method. Duration method is something little different because BCBS are saying what is the probability of default in next 12 months. Now question is that you may not default. If you have a AAA rating, you may not die in a default in a payment in next 12 months. But what guarantees that another year or another year you have become AAA to become a AA, then become BB, and then you default it. So if you look at these things, the duration method is what is trying to do is trying to replicate that. What is the probability of your default in the next 12 months must be based on these three possibilities, and then arrive at what you call the and if you take time is homogeneous, that happen, then you have some probability. Otherwise, what will happen? Most banks will find their most highest rated customers are not last 3 years. Within 1 year, they have not defaulted, but they have defaulted maybe other 5 years or 4 years. How do I take into that particular informations? That is what duration method does. Okay, I'm not going to the more details of it, but duration method's philosophy is this, and we'll see that the results. What it happens, the probability of default which is being computed on the cohort and what is the duration is different substantially, and that is why BCBS says that minimum probability of default, even in AAA rating, even if IRB approach says 0, it must be at least 3%. I think 3%. Okay, 0.03 or something. So this is the duration method. Next. So this is the results. You see that what is the result? You can see the probability default, which is based on data. Okay, 100 million INR is the common sample. 6 years data we have crunched, and this is the result. Next. So then you can see that 0, 0 is coming. Okay, and probability of persistence is same rating grade. This is very important to evaluate your default probability matrix. If this, the basic idea is that any good default probability computational method, either cohort or duration, must ensure the persistence in the same rating grade over 12 months should be very high. That means diagonal your this matrix diagonal elements must be predominantly much bigger than the non-diagonal elements. That is called persistence. That means you do not change your grade so easily within a year. If you do not change the grade so easily there, then your probability of remaining on the same grade should be very high. And that is the general kind of observations based on the external rating data of the. So probability default of borrowers also change. You had 0, you go to next. When you go to the duration methods, same sample, common sample, you'll see that 1 year to 6 years, you are getting 0.0029, 0.003%. It is getting different. Next. And persistence also changes. And if you compare this persistence probability from this actual data, we have crunched, basically data is coming from the, we have done it this kind of result for 3 large, very large Indian branches, which are having more than 1,000 or 1,500 or 2,000 branches. And this is the kind of a data, after we analyze, we got it. So basically it says that your rating system is not sufficiently robust enough to allow you to go to IRB mapping approach. Next. Okay. Go to next screen, please. Next. Yeah. So default for this is the we're comparing. This is what the S&P Global their Indian counterparts. You see the AAA, even AAA 96.96%, which is much less than much higher than what we have observed in these things. So that shows that your rating systems, how fragile is, how inconsistent is there from the observed kind of rating system based on the corporate borrowings or the corporate debentures or corporate loans, and that is what is getting there. So this is the external rating systems, and we saw the internal system. This kind of differences obviously will not allow a regulator to allow you to go to IRB approach. Next. So this is the concluding observation of these things. Transition matrices based on bank setting data are perceptibly different from the general accepted transition matrices for corporate bond in India or developed countries. The persistence probabilities for higher rating grades is too low. Okay, next. Then we are talking about model validations. This is the standard methodology validations of there. Basic thing is backtesting, that you have a sample based on it, you data, you have built the model, and there is a validation, another set data. How does it perform on that set of data which you have not used for model building effort? Okay, plus homogeneity, how quickly model is changing if you bring one more year data or two more year data. So robustness of the model. Homogeneity means homogeneity over time or homogeneity of same borrower, same customer pool, and you take one pool and another pool, you just divide it and it changes. That homogeneous, it is not homogeneous. Next. Okay, next, please, next. Okay. Now let us look at the model for IFRS 9. IFRS 9 requires two model requirements: expected credit loss, lifetime expected credit loss. A bank has to build such models in 3 steps. Step 1. Step 1 should be segregation of credit exposures. That means exposures that have not experienced any deterioration from its date of initiation or amount is lower than a threshold. For this exposures, a 12-month ECL is recognized in Basel. As in Basel, step 1, you do your segregation of credit. Those exposures, you do it. That is your step 1. Step 2 is that identify exposures that have experienced significant increase in credit risk. So you have a lifetime ECL is recognized. A survival model for defaults covering this lifetime asset is to be built. Step 3 is that which has actually experienced default or doubtful. For this asset, lifetime ECL is worked on the net exposure. That is, it is a not carrying cost. In the step 2, you are using as a carrying cost survey model files. You are taking a carrying cost. You are whereas the step 3, it is after provisioning. Okay, that is the difference between that. That is, you have already provided for that. For that, I will not penalize anything. You take care of that provisioning. After that, you see that what is the expected credit loss, which is not true for step 2. Okay, this is the 3 modeling requirement agreement. And next, that's the end.
Yeah. So before I open into Q&A session, I would like to quickly thank everyone for joining this session. Also want to announce a very interesting thing. The next session we intend to do 4 weeks from now by picking up a very interesting and important topic called climate-related financial risk, which is being advocated by Basel Committee. And please block your calendars for Thursday, November 12 at 5 p.m. So I would like to open the session for Q&A. Once again, before that, let me thank Dr. Nag for very nicely articulating various aspects of modeling. The entire philosophy of this session was to ensure that all of you get a glimpse of the key aspects of modeling when it comes to Basel or IFRS 9, how to go about, what are the various types of models, and also to briefly touch upon how today's technology helps you to carry out this sort of modeling exercise with ease. So with this, let me open the forum for any questions. We'd be more than happy to answer. Maha, can you unmute everyone, please? Once again, my apologies. I saw some questions. There were some network issues, so apologies for that. And modeling as a subject, it is one cannot really, do justice in a 1-hour session. It definitely requires a lot of understanding, and also some background of statistics would really help you quickly to grasp. So this is in response to one of the questions in the chat window. Dr. Nag, there is a question on when should we use heuristic modeling or statistical or AHP modeling? How should one decide on that? Can you respond to that?
Yeah. See, when you do not have Suppose you are starting a bank or you have started in a new product segment in any area. You do not have sufficient data to crunch it and get this, either statistical modeling. Okay, AHP is different. I'm talking statistical model. So when you do not have this data, then maybe heuristic model is the best way of doing. For example, when you have a camel slating you are doing, suppose you have only 100, 200 banks to be, subjected to camels or something. So your data size cannot be more than that. It will be. So you have no other alternatives to carry out these kind of things, and they are very difficult to, take the data and put it in a structured fashion so that the data quality is a certain acceptable quality, and then create these statistical techniques. It's may be done, but it's a sometimes may not have that kind of a a marginal incremental kind of value. So it's better that you decide about the heuristic model, because heuristic model is based on the supervisions. People, when we did in FSC models, AHP model, the heuristic model was built first by the a workshops conducted with all the supervisors who are on the on-site inspections. Then we created the heuristic model, and then we subjected to the HP kind of things, and we bring the HP model. The difference between the HP and the your heuristic model is that the HP model is taking the inputs from the domain people about the relative importance of a particular, and then create the API techniques. And otherwise, a standard heuristic model weights are given also by the your domain people. This is the only difference. So that AHP depends on the domain knowledge, definitely. It is based on the domain knowledge. Only thing it does, it makes it consistent. The inconsistent domain knowledge it brings out clearly and makes it an iterative process, and gradually arrives at the final weighting diagram for all the the heuristically decided the your parameters. That is the only difference here, and that is why AHP is a very preferred one if you are able to do it, because there is a standard softwares are there which is a very cost you can use there. So AHP model is a very useful because it marries the domain knowledge, very extensive domain knowledge, along with the operation research framework, which is a very make it a consistent. That is your preferences may not be consistent by itself when you do it by yourself. The HP process only allows you to make that to be consistent. That is the difference.
Thanks, Dr. Anand. There is one more question from Ashutosh. His question is, on what basis variables within bracket ratios selected for MDA without literature review?
See what Altman did, or everybody does it. Generally, what you do, I can give you the simple example. Suppose you are saying that income depends on variable x1, x2, x3, say your occupation A, blah blah, and you have multiple things, and many of them are very correlated, some not correlated. Now, individually, they may each one may explain 20%. That is, if you take y and x1 may be able to explain 31%, 40%. Okay, like yours, my residual will be much bigger than that. So, what is important for us? What it does basically, it essentially tries to find out that you take all possible variables, production possible, and all these variables you put into this program where you are churning this data and finding out gradually which is the best predictor, relatively best predictor than others, and then selects those which are, after you add another one, it does not add any value. So after this 5, if you add a 6th variable, it does not improve upon your predictive powers. Then why should you use it? It only introduces more noise. Okay, so this is the iterative process, and this iterative process is called the by stepwise regression is that thing. Basically, you have 100 variables and you have only one outcome y. You want to predict this 100 variables using 100 variables y. You can take one variable, you can take 100 C2, 100 C3. So many combinations are there. Which combination is the best? So that is what the people do it, and they can get the answers, because the computer crunches, you can give a methodology that how do I increase, okay? So you can say that which has the highest correlations with my y-axis, take this first one, and then gradually take all this first one, try to decide about which are the best. So there are 20 variables are there. Everybody is correlated to y, they have more than 0.8. I take all them first, and then I will find out which are redundant. If you drop it and keep it to 19.1, I don't lose anything. So there is a methodology is there. You don't stepwise regression, all the methodologies there. You gradually arrive at the least number of variables, which allows you to give maximum kind of predictability. And you don't really gain much by bringing others. That's the basic idea. And there are criteria are there. Because as soon as you bring a one variable, you are also a cost. That means you are using more kind of information without adding more informations as a real information value to your outcome. Have I answered the question?
Yes, sir, there is one more question. Can you please explain a bit more on Mann-Whitney test that is used for variable selection?
Yeah,
which was mentioned, and also use PCA for variable optimization.
Yeah. Mann-Whitney test basically does what it does basically. See, if I give an example like in gender, suppose you have a variable which is a 5 levels. Okay, say occupation. I have my customers. I have divided into 5 occupation groups. Now, what do you expect? The distributions of this your default distributions or thing, whatever is there, you can does it okay are identical almost, but statistically, I'm not saying exactly. Statistically, there is not much difference. If there is not much difference, then this particular variable is not a good differentiator. Correct? That it doesn't matter. See, for example, I take height, suppose. Does the height or weight of a customer, does it have affect the probability of default? So if I have a defaulters and this is distributions based on this the heights, some distribution, I find there's no differences. Okay, the distribution of heights of the defaulters and distribution of heights of the non-defaulters are almost identical statistically. I mean, that is, you cannot really say that there's significant difference. If the means change substantially, that means the defaulter's height is 5.5 and non-defaulter's height is 6 feet. That means height has a very important issue. People who are more height then is more likely to not to default. And I will expect that variable is important. Mann-Whitney test gives you that are these distributions really different non-parametrically? Because I do not know what distribution it follows. Does it follow normal? Does it follow some non-normal? I do not have any idea. Then how do I test it? I may not be able to do a property test. Then I do non-parametric test. There are so many non-parametric tests out there. Mann-Whitney, like Kolmogorov spin-up test. These are all tests. We are trying to find out that distributions are almost same on one. Graphically, if I say look it, but it is going beyond graphics, it tries to bring in some kind of statistical test. Have I explained that? Is it okay? Yeah. Okay. And second question is Mann-Whitney test. Another question is there.
Don't we use PCA for variable optimization?
Yeah. You see, your multivariate discriminant analysis is certain kind of a PCA is involved. See, principal component analysis says that which is the linear combination of a 20 variables, suppose is there, which is the best linear combination that explains 80% of the variation in the outcome variable. See, what statistics design does that you should be able to variability in the outcome variable should be able to capture. Okay, so this is the 5 variables, the principal component is explains 80%. The first principal component, you can use it. In some sense, a linear discriminant analysis is doing that only.
Great. Any other question from anyone? Otherwise, we would like to conclude. Yes, I think there are no other questions. Thanks to all the participants for joining this webinar. And a very warm thanks to Dr. Nath for this lively presentation. A very interesting presentation which helped everyone to understand the journey in the modeling space, especially to address Basel and IFRS requirements.
Suresh, if anybody has any specific questions or any kind of a reference they would like to get it from me, they can write to me, ashok.nag@gmail.com.
Sure. Yeah. So if there are any questions, feel free to write to us either at resolutions@jmrinfotech.com or Basel practitioners, supported Basel practitioners, or ashok.nag@gmail.com. We'll be more than happy to revert to you. And also, if you need any support in this journey, by way of any guidance and consulting support, feel free to reach out to us. We are here to help you in this journey. And thanks, everyone. Thanks for joining this webinar. Have a wonderful day, wonderful noon, wonderful evening. And let us meet again on 12th November for another very important session on the Basel area. Thanks once again, and bye for now.